All right, gang. All right, problem two. Now, this one I think on the practice test gave a lot of people trouble. Um, so let's really focus on figuring this thing out. Now, it says Charlie leaves his house. His position as a function of time is shown in the graph. Um, Now, I've got these three different sections. I've got 1, 2, and 3. All right, so let's see. I've got 1, I've got 2, and I've got 3. Now I have to treat all three of those separately. And we'll see that A, B, and C actually ask for the velocity in each different section. Excuse me. Um, so right now, to find velocity on a graph, I'm going to do the same thing I did in the last example. So I'm going to do, oh no, I don't want to be on highlighter. I want to be on pen. I want to, and let's make this a different color. Let's make this purple. All right, so I want xf minus xi divided by tf minus ti. Okay, so that's going to be the equation that we use every single time. Then we're just going to do the same thing over and over again. So let's do this. Let's focus on number 1, so section 1 right here first. So if I zoom in a little bit, I know that I need to have xf, xi, tf, and ti. All right, so I'm going to find all of those. Now, my final position, remember that it's going to start here, and it's going to move to here. So my final position, I'm going to focus on that point first. So let's just go ahead and let's look at what we think the position is. So the position is going to be here. So halfway between 0 and 50 is 25. So my position, my final position, is 25. Now my initial position, okay, for this dot up here, well, I don't even have to trace it all the way over because there it is. It's 150. So my initial position was 150. Now if I go down to time, okay, let's use my color again. Now this is my final point here again. Remember that, okay? So my final point I'm going to trace straight down halfway between 10 and 20 is 15. Okay. So halfway between 10 and 20 is 15. That's my final time. All right. My initial time, if I go all the way back up here, I'm going to look, well, that's just 0. So my initial time is 0. Okay. So my final time is 25. So remember, I'm going to go back now to this equation up here. So first I'm going to plug in final time, xf. All right, so that's going to go 25 minus initial time of 150. All right, so I'm taking that and putting it there. I'm taking that and putting it there. Now I'm going to take my final time and go 15, and my initial time is 0. Now let's erase those to make this a little nicer looking. So I've got 25 minus 150 divided by 15 minus 0. So if we do 25 minus 150 on our calculator, we're going to see that it's negative 125. And on the bottom, I'm going to have positive 15. Now, that's good. I'm glad that I got those things. Let me grab my calculator real quick, guys. Hold tight. Alright, I can't find my calculator. I wonder what happens to the video if I swipe. Okay, so I'm trying to do 125 divided by 15. And I'm going to see that that is, are we still recording? I think we're still recording. Negative 8.3. All right, now I'm going to rewrite this down here so I can box it in. And that's going to be negative 8.3 meters per second. That meters per second is really important, okay? So let's box that in. Now, you might say to yourself, Mr. McSparron, negative 8.3 doesn't sound right. Why is it negative? Well, if we look back up here at our graph, the graph is going downhill. Anytime my graph goes downhill, I should have a negative velocity. So that makes perfect sense that I would see that negative in that section. Okay. All right, now let's go back and let's go down and find, we're going to do time interval 2, so this time interval here. Now, a bunch of you guys are going to draw in XF, XI, TF, TI, all that. I don't even want to do that. Let's notice that that section is flat. So it's flat at 25 meters. Well, that means that from 15 all the way up to 25 seconds, it's not moving anywhere. It's just sitting right at 25. So if we think about what's the velocity when something's not moving, that's easy, guys. It's 0 meters per second. So anytime this line is flat, our velocity is 0 meters per second. All right, now let's do the last piece here. Find Charlie's velocity for the third time interval. So now I'm going to do this one. Whoops, I'm going to do this one here. All right, so now I've got my final point here, my initial point here. All right, and we're going to fill in XF, XI, TF, and TI. All right, so let's go find my initial position. All right, so I wonder if I do this. Let's do that, and let's make this thing smaller. There we go. All right, so I trace it all the way over, and I see my final position is 125. Let's write that in here, 125. My initial position, go all the way over here, was 25. So it started at 25, and it went up to 125. Now my final time is 35. But my initial time, where we started, is 25. Oh, good. It's going to be easier math. All right, so I've got XF minus XI. Remember, I'm using this thing. XF minus XI. That's always written on the board, by the way, guys. Divided by TF minus TI. All right, so 125 minus 25 is just 100. And then 35 minus 25 is 10. So what I end up with, 100 divided by 10 is 10 meters per second. That is my answer, and that's it for that page.